Hello everyone and welcome to this video. So let's talk about vectors and vector similarity measures. As a data scientist, while designing and developing AI and machine learning solutions, you'll often work with vectors. For example, numerical features in your dataset can be represented as vectors. A text document can be transformed into a vector using techniques like text embeddings. So what exactly the vector is? A vector is essentially a point in space. A one-dimensional vector is a point on a line, a two-dimensional vector is a point on a plane, and a three-dimensional vector is a point in a 3D space. Of course, higher dimensional vectors extend this concept into spaces we cannot visualize, but they are mathematically similar. In AI, these vectors are used everywhere. Whether you're building a recommendation system, clustering data, or performing text analysis, vectors are a common representation of your data, and most of the time you find yourself comparing these vectors. Now let's have a look at this scenario. Imagine you're building a product recommendation system for an online store. The goal is to recommend products to a user based on their preferences. You have a data set of 4 different products and you have information about the product price and product rating. Each product can be represented as a vector in a two-dimensional space. Now, let's say that a user is looking for a product with price equal to 60 and rating equal to 4.5. Now, in order to find the most similar product to the user's preference, you need to compare the user's vector with each product's vector in the two-dimensional space. You can use different mathematical techniques to measure similarity or distance between two vectors. The first one is Euclidean distance. It measures the straight line distance between 2 points. The smaller the distance, the more similar the product is to the user's preference. The second metric that can be used here is cosine similarity. It calculates the cosine of the angle between two vectors. Unlike the Euclidean distance, which focuses on the magnitude of the difference between points, cosine similarity measures the direction of the vectors. This makes it useful when the magnitude of the data points isn't as important as their relative orientation. For example, in our product recommendation system, you can use cosine similarity to compare the user's preference vector with each product vector to identify the most aligned direction. This is especially helpful in scenarios where data features may have vastly different scales, but their relationships matter more. This makes the cosine similarity very useful in different applications such as text embeddings and search engines, recommendation systems, clustering and classification, and even retrieval augmented generation or RAG systems. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.